Technical Installation, welcome to our webinar, Towards Reducing Embodied Carbon in HVAC with CLIMAVER. I am Hendrikje, the Marketing and Communications Manager of the business unit Saint-Gobain Technical Installation, and I will be hosting this webinar and introducing the speakers in a few moments. First, I would like to say a few words about Saint-Gobain Technical Installation. We have been delivering sustainable installation solutions since 1937 to all technical markets such as industry, marine and offshore HVAC, and OEM markets. We have a worldwide presence through our two international brands, Isover and Kaiman, and a network of local brands. We are global and we are also local because we have local production sites in many parts of the world. We have local teams in most parts of the world, which allow us to be close to our customers. We have an expertise in an array of insulation materials, from mineral wool with glass wool, stone wool, the ultimate light stone wool, to elastomeric films. Today, we are going to focus on towards reducing embodied carbon in HVAC with CLIMAVER. Just a few practical instructions. You are, of course, you can raise your questions and answers in the chat, directly in the chat. You can start raising them during the webinar right now or at the end as you wish. We're going to dedicate some time at the end of the webinar to address your questions. With a question in mind, can we achieve healthy, comfortable, and safe zero-emission buildings? The second part will be focused on our solution, on our self-supporting duct solution, CLIMAVER, and we want to show you here how CLIMAVER can help you reduce the carbon impact in buildings in your HVAC system. And then the third part will be dedicated to questions and answers. We have two speakers today. We're very proud and happy to welcome an external speaker today, Francis ALLARD, a professor at the La Rochelle University and CNRS, president of TIPEE, and a former president of REVA. So a huge expertise in HVAC, in building, energy, etc. And we have Elodie, the HVAC product manager at Isover France. Elodie is a chemical engineer with an extensive experience in R&D and product management and a great experience now in HVAC. So I'm not going to make you wait any longer, and I will welcome Francis. The floor is yours.
Thank you, Hendrikje. Good afternoon, everybody. What I propose today is to try to answer to three main questions. What have been the main drivers of the evolution of the building sector's policies in the last 20 years in Europe? What are the main evolution due to climate change and pandemic crisis? And what are the new questions pointed out by zero-emission buildings? In fact, the foundation of Europe was made on energy supply problem. The two main treaties on 1952 and 1957, the Coal and Steel and Euratom Treaty, were dedicated to energy supply in Europe. But the energy use was not a real concern. And for instance, in the building sector, we had no European initiative before 2002, excuse me. In fact, here you have the situation in 2001. It was a survey we did with a Swiss colleague, Claude Alain Roulet. And what we have shown in this study is that in Europe, it was a real mess. All the member states didn't have at the time regulation or building code. And the one who had building codes had a different approach, different methodology, and different criteria. So it was decided to strengthen the role of the building sector in the energy use in Europe. The building sector represents more than 40% of European energy use, and also more than 36% of CO2 or equivalent CO2 emission. But it has a high cost-effective energy saving potential for Europe, and it's an important economical sector with more than 2 trillion euro annual turnover. So it was decided in 2002 to launch new EU legislation about building called Energy Performance of Buildings Directive. If we look at the past, the milestones of the evolution of the regulation is shortly represented here. From the first one, 2002, EPBD. Then 2008, we had a directive about the use of renewable energy. It was a 20-20-20 directive. 20% of renewable energy in the energy sharing. 20% less emission of CO2 equivalent referred to 1990, and 20% more efficiency in the energy use. Then, a third step, important step, was in 2010, when the EPBD was rewritten. In fact, it was defined at this time a general roadmap towards nearly zero energy in building, which will impact all the national regulation in Europe. And then in 2012, the first directive on energy efficiency focused in the building sector. It's a huge directive, but on the building sector, focused on building renovation with a 3% renovation per year of public buildings. So it's clear that the European building policy has been driven by energy for more than 20 years now. But the world is changing. The global warming is important. We can feel it now. And with the reports of the IPCC every year, we can understand more the evolution. So we have to limit the evolution of temperature. The global warming target is between 1.5 and 2 Celsius. And if we want to do that, we have to reach nearly zero emission by 2050. In Europe, energy accounts for more than 70% of the green gas emission. So it's absolutely mandatory to decarbonize the EU energy system. What we learned also from the pandemic crisis of 2020 is that the role of HVAC systems and ventilation is crucial to ensure healthy, comfortable, and safe buildings. So we established a new basis for European building policy. The recast of the Renewable Energy Directive strong increase the share of renewable energy in the energy panel in Europe, around 42%. A new recast of the Energy Efficiency Directive has been made also last year in order to improve the energy efficiency by more than 11%. A new recast of Energy Performance of Buildings Directive is planned, has been discussed, and is planned to be launched in a few months. And of course, more accompanying measures have been decided. It's a European climate target plan. So in 2023, the climate target plan has been launched. In fact, the ambition of Europe is to be the first neutral continent by 2050. In order to reach this goal, we have to reduce the equivalent CO2 emission by 55% in Europe. For the building sector, it means more than 50% until 2030. And also, of course, to decrease the energy consumption, the final energy consumption of the building, and more precisely, the energy consumption for heating and cooling by 18%. Excuse me. So now it's important and mandatory to focus on more energy efficient and less carbon intensive buildings. So the goal is clear. We need in Europe, if we want to reach our target, we need to have a building stock with zero emission by 2050. It means that new buildings must be zero emission by 2030. And even for the public building in 2028. So the member states should renovate also 16% of the worst performing non-residential building by 2030 and the worst performing 26% by 2033. The second part is that we evaluate the building now, not only for energy, but on their environmental impact. So the life cycle global warming potential has to be evaluated for new buildings for 2033 in accordance with the level European framework. So it's like a change in a paradigm. We were focusing on energy. Now we have to deal with global environmental impact of buildings. And beyond energy performance, of course, member states should address for new buildings important dimensions going, namely from healthy indoor climate condition, adaptation to climate change, fire safety, and so on. So, what about the new EPBD recast? So the main element is that zero emission building should not generate carbon emission on site. So the directive has been discussed now in a public panel last year, and at the end of the year, the Council and the Commission of the Parliament and the Commission itself, they reached a provisional political agreement. Now, this has to be formally voted, both by Parliament and Council. But what does zero emission building really mean? First element, the life cycle global warming potential of the building should be zero. Also, the overall energy used by the building must be carbon free. It means no local emission of CO2 in producing energy on site. And the construction work, as well as the material used, and the equipment, the HVAC, for instance, of the building, should have a carbon impact as low as possible. This points out questions. Should all gas boilers disappear? Which energy vector to be used? Electricity only? Does decarbonation mean electrification? What kind of material should be selected? Type 1, reused, biosourced only? What about indoor environment quality? The environmental impact of a building is not only with the outdoor environment, but also with the indoor environment. Of course, we certainly can achieve healthy, comfortable, and safe zero-emission buildings in Europe as we achieve zero-energy buildings. However, it's important that indoor environment quality should be addressed clearly in the European directive. The life cycle approach of building evaluation needs a strong effort from the designer, but also the manufacturer in order to document their products, material, equipment, and so on. And it's a strong modification of the way to design buildings. The principle of zero local emission means a drastic limitation of fossil fuels and a strong increase of carbon-free electricity, green gas, hydrogen, or more renewable energy sources. We will need also a strong effort in technology developments in order to reduce first drastically the embodied carbon of materials, as well as to adapt the HV system to carbon-free energy sources. Thank you, and I let the floor to Elodie now.
Thank you, Francis. Okay, so now let's jump into the second part, which is how to reduce carbon impact with CLIMAVER. So just to be in the same trend as Francis, of course, in France, we had the same things. As you said that before, we had thermal regulations, and the last one being the RT 2012, on building energy reduction, so on building insulation and high insulation. In 2016, in France, we had a new label, which is E+, C-, which started to promote the calculation of carbon footprint and to take into account the carbon footprint of the building. And now, since the 1st January 2022, we have a new regulation, which is an environmental regulation, the RE 2020. And in fact, I think in Europe, we are the first in France to, well, France is the first to have an environmental regulation. And in this environmental regulation, we have 3 pillars. Of course, we have the energy consumption, which is mainly linked to the insulation of the building. But we have two other pillars, which are carbon impacts and carbon impact of the material used for the construction and carbon impacts of during the building life. And the third pillar is summer comfort. I will just give you an overview of the 6 key indicators that are in our RE 2020. And keep in mind that all those indicators have thresholds that should not be above, and this is that we should not go above. And of course, they should all comply with the RE 2020. We have 3 indicators which are linked to energy consumption. The BBO, which is linked to energy sobriety, and after we have 2 other indicators which are linked to energy consumption. We have 2 other indicators in the second pillar, which are linked to carbon impact regarding the building. So the first indicator being the energy carbon impact, and the second one being the construction carbon impact. Construction carbon impact meaning the sum of all the products and materials which are used to make the building. And the third pillar, regarding summer comfort, it's an indication in degree hour, which is how many hours in a year you should not be above a comfortable temperature. And in fact, in France, if this number of hours are above 1,250, then you should review what you're doing and check everything because you're dismissed. As you can imagine, all those 6 indicators are linked to each other. So when you move one to lower it, well, it has an impact on all the other indicators. So it's a bit tricky to comply with everything, but now we need to because we have the RE 2020. I will now focus on one of the indicators. As you probably guess, it's the construction carbon impact indicator. Okay, so let's just have an overview of what's happening with the construction carbon impact indicator. I told you there are thresholds, so it's already quite difficult to be able to comply with them. And those thresholds, they are decreasing every 3 years. So just for you to have in mind, between 2022 and 2031, so within 9 years, the indicators, the thresholds, will decrease a lot. And for offices, they will decrease of about 40%, and for school, of more than a third, which is quite significant. All the other tertiary buildings also have the thresholds. They are not decided yet, but we should know them by the 1st of January 2025. There is also something that we have in mind that it's not always easy to calculate the global carbon footprint, construction carbon footprint of the building, because today, not all products and not all solutions have local EPDs. So it's also a challenge, and it's also a booster for the industrial to do the calculation and to promote those calculations. Okay, if we are back on the construction carbon impact, Today, to calculate it, the buildings, all the raw materials of the building are divided into 14 sections. And so with what Saint-Gobain says is that in tertiary buildings, if we take an average of the weight of each section, then on the top 3, you have the 8th section, and the 8th section is HVAC. Here, it represents an average of 14%, and you will see in the next examples that 14%, yeah, it's between 14 and 20%. So it has a huge impact, this HVAC section, on the global carbon footprint of the building. In each of the 14 sections, you have different subsections. So for instance, here you have for the section 8, which is HVAC, which is the one so we will focus on today. You have the different subsections, and the one we will focus on is of course the 8.5, which deals with pipes and duct networks. So here, what we know is that we have kind of a problem and a big challenge, but don't worry because there is a solution. One of the solutions is CLIMAVER. So what is CLIMAVER? Some of you may know, some of you may don't know yet, but you will. So CLIMAVER is a system. It's a system made of a rigid board. So it's a 3-meter length per 1.2 meter board with 2 facings. One of the facing being aluminum foil to have air tightness, because from this board we will make a duct. To make a duct with this board, well, we need dedicated tools and a dedicated method, which has been proved over the years. And all of this, it makes CLIMAVER. So now let's have a look, and you will see someone manufacturing a duct, sorry. So you have a special square, a special ruler, which helps you to have a direct reading of the internal section of the duct. And it also helps you to have a straight cut. So here you can see that he's doing the cuts to after make the duct. So he will do the 4 cuts with the good dimension. He can of course do it on site. He just needs to have something flat of 3-meter length to be held on. And after, once the cuts are made, then he will just remove the extra glass wool from the panel. Yeah, sorry, I didn't tell you, it's a 55mm glass wool board. So of course it's insulated because you have at least 25mm of glass wool. And then what he's doing, that he's bending the board to make a duct. And then he's stapling the duct to have some strength, to have some mechanic, and to get the air tightness. He's using the special CLIMAVER tape, which is very important because with this tape you can reach very, very good air tightness. And here it is, he made a board. So as you see, it's quite fast to make a board. In France, we say that we can make a duct. Sorry, it's quite fast to make a duct. In France, we say we can make a duct within 5 minutes. While in Spain, they used to make it within 3 minutes. At the end, all you need is the method and the tools. So here you have an indication of the tool that you should use to make the duct from a board. So you have the cutters. You do the cutting at the right dimension. Then you bend, as you've seen, you bend the board. You staple the stripe, and then you tape it. And once it's taped, then you have a straight duct. Okay, it's good to have a straight duct, but of course, in duct network, we don't only have straight ducts. And what's very good with CLIMAVER is that the method tells you how to make every shape from a straight duct. So here, for instance, you will have an example with a 90 degrees elbow. So you can see that you use different knife, and you use a glue here. So not the staples to have the mechanical strength. So from the board, then you do the cutting as you should. To have different pieces of duct. Those pieces of duct, you rearrange them, you stuck them to each other to have mechanical strength, and after you tape it to have the air tightness. And here, 90 degrees elbow. So from the board, you can make every shape that you want, because you can see you have some offsets, you have some reductions, you have some T ramification, you have everything. You can also, of course, make a connection to circular duct and a connection to rectangular duct or rectangular frame. And this is this is quite easy and fast to do. So what you need to have in mind is that CLIMAVER is, of course, a low carbon footprint, and that's why we speak about it today. But it's been used for more than 50 years. So it's a proven solution. It's not a new solution. It's something that exists. It's something that is available. Well, it's more known as self-supporting ducts. And today, in Europe, we sell more than 4 million square meters per year. So you probably have some CLIMAVER somewhere around you. It's a smart conception, as you've seen. It's been thinking for more than 50 years, and it has many benefits. Regarding the low carbon footprint, I will come back to this later. I just would like to say for the French colleagues and also for the others that there are EPDs and there are FDES, which are the local EPDs in French. And CLIMAVER is made of recycled glass, of 55% of recycled glass. As I told you, CLIMAVER is a board of 25 millimeters, and the 25 millimeters which are composing CLIMAVER, it's not any raw material, it's glass wool. So of course there is sound absorption. You see that you can make it on job site with the dimension you want, with the shape you want, so you can really adapt when you want and when you need. CLIMAVER is made of lightweight. CLIMAVER is made of glass wool. It's a rigid board. Don't think it's weak. It's not weak. It's rigid. But of course, it's lighter. And as it's lighter, then it's easier and faster to install. And in fact, only one person can install a duct of 1.2 meters or even 2 or 3 ducts pre-assembled because it's lighter. Logistic is optimized. I guess you already guessed it, or you already found this advantage because as we can transport only flat that are after transformed into duct, and of course, logistic is optimized. And regarding air tightness, in France, we have an AVI technique. So we have class C, so ATC 3 regarding CLIMAVER. And if we focus, so from European scale, if we focus on EN 13403, then we have class D, which is ATC 2 and 1. So it's a very air tightness duct. Okay, so now let's discuss about how CLIMAVER can help you to reduce carbon impact regarding construction raw material used for the buildings. So we didn't do the study ourselves. All we did is the local EPDs, but after we asked 2 engineering offices that are well known in France, which are Tribu Energy and Artelia, to do some investigation. So they proposed us 4 buildings. In those 4 buildings, there were 2 schools and 2 offices. Why we took school and offices is because we had the thresholds from the RE 2020 on schools and offices. So we did investigate 4 buildings with school and offices. And after the assumption we took is to say that all ducts were switched into CLIMAVER A2 Netto, whatever if they are rectangular or circular, but circular with the diameter above 160 millimeters. If not, from an aeroic point of view, it's a bit tricky. And this with and without insulation, because okay, CLIMAVER is a pre-insulated duct because it's made of 25 millimeters glass wool, but the first purpose of CLIMAVER is really to transport air. So that's why duct with and without insulation were converted. Okay, if we have a look at the first example, and after you will see the 3 others. The primary school. So here you have the global carbon footprint of the whole school. So we are at 807 kilogram equivalent CO2 per square meter. In this 800, you have 143, which is only section 8, so which is only HVAC. It represents 15% of the total carbon footprint of the building. This section 8, in this section 8, so you'd remember you have several sublots, several subsections. So if we focus on the subsection 8.5, which is ducts and pipes network, well, you of course have a lot of things other than ducts, and this is the dark gray base where you have the CO2 footprint of other components other than duct, so such as flexible, valves, traps, stuff like that. And after you have the contribution, the CO2 contribution of the duct. And if the ducts are in CLIMAVER, then the contribution is only of 12.5 kilo equivalent CO2 per square meter, which means that there could be a reduction of CO2 footprints of the global of the construction carbon impact of 30 kilogram equivalent CO2 per square meter on subsection 8.5. Same gain on section 8, and of course same gain on the building, which means reduction of the carbon footprint of the building of 3.8%, which is huge. So only by using CLIMAVER. And you will see in the other example, the reduction is significant every time. The second case, the second building, which were another school a bit bigger. Well, here, the section 8 was representing only 11% of the total carbon footprint, construction carbon footprint of the building. By using CLIMAVER, then there is a reduction of 15 kilo equivalent CO2 per square meter, which is linked to almost 2% on the total building. If we now go to the offices, then the reduction regarding construction carbon footprint is even bigger. Here with the, let's say, small offices, because it was 500 square meter offices, section 8 was representing 20%. So by using CLIMAVER, we could have a decrease of the carbon footprint of 41 kilo equivalent CO2 per square meter, which was almost 5% on the total building. And in the second example, which were bigger offices, well, larger offices, the global carbon reduction was even above 5% compared to the total carbon consumption building of the building. This is now my last slide. I hope that you've been convinced that CLIMAVER is a very good solution to reduce significantly building construction carbon footprint. You need to keep in mind that it's really a complete solution. So you need to have the good boards, the CLIMAVER boards, the dedicated tools, and to make it with the dedicated methods. And after, everything will be good. There are many advantages other than reducing the carbon footprint, such as sound absorption, fast insulation, and I didn't say that, of course, we are A+ regarding VOCs. If you want to try it, well, contact your local Isover team. Thank you. And if you have some questions, Francis and I will be more than happy to answer.
Yeah, so thank you very much, Elodie and Francis. Very interesting. So I think indeed we have learned a lot about how the regulation is changing from energy efficiency only to carbon footprint reduction. And we have also learned how CLIMAVER can be a solution to reduce the carbon impact of buildings. We have a few questions in the chat, and if you want, it's time to raise even more questions. I will start maybe with an easy one. This is a question, I think, for Elodie, how to learn the CLIMAVER installation method?
Yeah, it's a very good question. There are tutorials on YouTube. We have a leaflet, and contact your local team because there might be a local trainer. And in France, we have a dedicated trainer which can teach you within 2 days how to make the ducts. And in fact, it's a very good question because you need to learn the method. You cannot make CLIMAVER just on your own.
Okay, thank you. Another question, what happens with CLIMAVER at the end of life?
That's a very good question. Well, today we shut sites was last year, and what we did with CLIMAVER, and one of the constraints was that it was temporarily ducts, and we should do something with CLIMAVER end of life. Before there was nothing really that was done for CLIMAVER end of life because it was tricky to remove aluminium from the glass board, or the glass wood board. It's still a bit tricky, but today we have a solution and we can remove the aluminium, or at least the facings, from the aluminium board scrap it, and after we don't reuse it in our glass wool, but we revalorize it and we put it into bricks. Reuse it.
Okay, thank you. This one maybe, well, I don't know, it's maybe more for Francis. Why is the carbon reduction impact more important on office buildings than on schools?
In terms of the design. Example, you were focusing on the HVAC system. Of course, in most of the time in offices, the HVAC system is larger than in school. So it explains the percentage due to HVAC systems and ducts, particularly. But I don't think there is a general law.
That's true. Yeah, that's true that in France the thresholds are lower for schools.
Another question. Thank you. How can we clean CLIMAVER ducts? Same as metal ducts?
Same as metal ducts. We've
okay.
done some tests. There is a test called the erosion. So we did erosion tests with a rotating brush and with the pressure air with wipes. And in fact, there is no erosion. There is no material that is coming off. The facing is very strong inside. So you just clean it as you used to. And what's very interesting with CLIMAVER is that you can make your trap where you want, and you can make it even when it's installed. You just need to have a knife because you need to open CLIMAVER, and after to have a H profile, so it's a dedicated profile to CLIMAVER, and the tape. So you can make it very easily and with a low cost where you want. But after you clean as you used to.
Okay, thank you. Then we have a question, I think it's more for Francis. What's the next step in concrete terms? What's the next step in the European regulation, and when is it going to happen?
What we expect this year to have the new recast of EPPD with the zero emission buildings, what I try to explain very quickly. Of course, then any member states have 2 years to translate the directive is in all own regulation, let's say building regulation. Roughly these are the main.
So in France we are in advance.
Yeah.
Well, we will see what's happening. But
no, the problem is that it needs a lot of work, European level. Will be very nice to have the same work we did for energy, to have a common method to evaluate the environmental impact of buildings. Because if you are building a building in Germany or in Spain, you will have different methods. So I think we should stress a little bit maybe the Commission in order to mandate them in order to define new standards for evaluating the building footprint.
Okay, thank you. For the GWP indicator, do you take into account A1 to A3, or do you take into account A1 to C4?
Well, that's module D. Fact in France, well, it needs to be on the INES database. But yeah, you take everything into account except module D.
Okay, thank you. I'm just checking. One more question on CLIMAVER. Are all CLIMAVER boards 25 millimeters thick?
No, you can have some 40 millimeters. And, I didn't say it, but in France, all the boards that we have are for fire reaction A2, D0, S1. And you can have some P and also some A1 if you want.
Okay, thank you, Elodie. One more question. Are the ducts working in negative pressure? Return duct?
Yes, of course. In fact, our IV technique is covering negative pressure down to minus 400 Pascal. So it can be Class C up to 400 Pascal. Honestly, we didn't test lower because it's most of the buildings are at max minus 400 Pascal. And to make those tests, we did a very big duct network with ducts from 1 meter to 1 meter, very small ducts of 15 to 20 centimeters. And we had some aging cycles. We had 60 aging cycles at minus 400 plus 10%, so minus 440 Pascal. We did it with the CSTV. So this is what you have in France, and you have an ETA, the global European assessment. And in the European assessment, you can go down to minus 800 Pascal.
Okay, thank you. One more question. How should designers evaluate CLIMAVER specs in their design?
Same as you do with the metal duct. Because in fact, we made some measurement of the pressure drop. The pressure drop in straight ducts or in elbows or in shapes, they are lower than for metal ducts. So what we say that, okay, the sizing, the dimensioning that you do with metal duct, you can do the same with CLIMAVER. One thing, and I didn't, just one number I didn't say, that of course CLIMAVER, you have thermal insulation, and you have a lambda at 10 degrees of 31 milliwatt per net Kelvin.
Great. I think for the moment we don't have other questions in the chat. There is still some time if you wish to raise questions. I don't know. Or is there anything, Elodie or Francis, you would like to add to the topic?
For me, I would just say try it, because really you need to try it to be convinced, and to try it, ask your local Isover team.
In my opinion, what I want to say is we are right now at a key point in the evolution of the design of buildings. As I mentioned in my speech, all the regulation till now were based off energy performance, and in Europe, mainly energy performance for heating season, most of them. Now we are looking at the global environmental impact of buildings. It means outdoor environment, of course. So the first step for me, it's a CO2 equivalent emission. That's carbon footprint. So I guess that we will develop it with other targets. And the second element is that we don't have to neglect the quality of indoor environment. And we never built building to save energy or to lower the carbon emission. We are building buildings in order to have safety, health, and security.
Yeah. And definitely the new regulation will take this into account, because now that we took a first step, where we won't go back, we will just go even further.
Yeah. One element also is that, as usual, in Europe and in the member states, we are focusing right now on new buildings. But of course, the strong part is the carbon footprint of the stock. And so that's why we have to develop strong renovation plan in every country, and not focusing only on energy savings, but on environmental impact.
And CLIMAVER can also help for renovation, in fact.
Okay, so I think we don't have any more questions, so it will be time to conclude this webinar. Thank you, Elodie, and thank you for Francis for this very interesting insight and very interesting presentation. I hope that we were able to answer your questions, and that you have now that you're really keen to discover CLIMAVER, how it works. We had a first webinar on CLIMAVER a few months ago, so if you want to review it, which will allow you to discover really the basics, how it works, what it is, all the benefits, then here you have the QR code to watch it. Or, of course, you can visit our website for more information about HVAC solutions, about technical insulation, or whatever you're interested in. or don't hesitate to subscribe on to our LinkedIn page, where we're making publications several times a week on everything what is important for us, what is maybe important for you around technical installation, about HVAC, about general problems in the topic. So thanks to everyone for listening. Thanks again to our speakers, and we hope to see you again during our next webinar.